Hi everyone, in this video we're going to go through the homework, test number 1. So do make sure you're doing these tests under test conditions. So no getting help from a tutor or friend or family. Just try to do your own work. Once you've done it, if you then want to go away and get some help, that's perfectly fine. But the purpose of doing it under test conditions is to actually see yourself improve and prepare for exam 1. So these should all be done without a calculator. Anyway, let's make a start. So question 1, we've seen quite a few like this now. And this test was very similar to the previous test. So just making sure that you're watching the videos so you understand the process that's involved. Now, a key giveaway to solve an equation like this is when it looks like a quadratic. All right, I understand it's got a base in there, the base is e, but when your base is to a power of 2x and the other base is to a power of x, you kind of should think, oh, I need to set that up as a quadratic and solve it. So you can see I've done that there. Just make sure that when you're using the null factor law, so just referring to this part here, when we have k plus 3 is equal to 0, so what we do is we subtract 3 from both sides, so we end up with k equals negative 3. So just be careful of that. That's how we end up with k equals negative 3 and k equals 2. Now when you're solving exponentials, so you can see then I've replaced e to the power of x for k. It can't equal a negative, so you can see that this is not a solution, so our only solution is e to the power of x is equal to 2. Now the opposite of base e is log base e, so if I took log base e of both sides, that's my final answer, and that was done very well. Just making sure, I did see this on a couple, that when you're writing a log, keep your base small and the argument, the number that's inside the brackets, needs to be the same size as the log font. Okay, so we don't want to see something like log E2 like that. It's not squared. It has to be the same size font as the log. And you'll be penalized for that. So please make sure you don't be sloppy with your handwriting. All right, question number 2. So this was quite similar to the previous one. I just changed a few numbers around, but the approach was very similar. So when I was marking these, I thought, oh, did anyone actually watch my video? Because if you watch the video, you should have got this one correct, because I showed you how to do it basically, and a non-complicated way of doing it. And you would have seen it also in my solutions, even if you didn't watch the video. What we have here is this log is being multiplied by 6, this log is being multiplied by 3, and our constant on the other side is 9. So to me, straight away, I can take out a common factor of 3. So if I go through and divide everything by 3, I just simplify it a little bit. So there, the 6 now changes to 2, the 3 now changes to a 1, and that 9 becomes a 3. So for people who still had these powers here as 6 and 3, I kind of thought, did you watch my video? I don't think so. Now there's nothing wrong with doing that. You could still put your powers there, a power of 6 and a power of 3. However, people are cancelling them out incorrectly. So I did see someone do x minus 2 to the power of 6 over x minus 4 to the power of 3, and then just cancelled these. So 6 divided by 3 is 2. Now I constantly see incorrect maths happening, so we've got to make sure that we don't make errors like that. All right, so these bases first of all are not the same, so we can't just cancel out those powers anyway. That's incorrect, cancelling of the powers anyway, because when we're dividing, we subtract our powers if they were the same bases. But these aren't the same bases. We've got x minus 2 and x minus 4. Okay, so let's put a cross through that so as a reminder that that is incorrect. As we got to the end, expanding everything, so I did try to see if we could cancel anything out before, but yeah, I had to go ahead and expand. Now when I expanded, I did end up with a nice quadratic. All right, I did see maybe 1 or 2 people use the quadratic formula, which is perfectly fine, but you should really try to factorize it first. And by doing so, it's like, what are 2 numbers that multiply to give you 36 and add to give you 12? So that's going to be -6. So x minus 6 squared. So that means x can only equal 6. And we should just check that our solution is valid. So just here with your argument, that should, when I substitute in that value of 6, it needs to be positive still. So 6 minus 2 is 4, 6 minus 4 is 2. So awesome, all good in the hood. All right, question 3, such an improvement on last time, but we're still getting there. So the asymptote was done really well, which is great. The x-intercept was done really well. Just make sure you get your coordinates around the right way. But the curvature of the graph, there were some that were really spot on, and it was good to see some of you got the point, what was it, 1.5, 1. Although I wonder how you got that unless you used a calculator. Maybe you could. I'm just thinking on the top of my head. So if you watched the video last time, I said try to make it so your argument is the same as your base. So to make that the same, I needed to let x equal 3. All right, so to make this part here equal to 2, I had to substitute in x equals 3. And then another point that's easy to do is letting this equal 1. And to do so, I had to let x equal 2. So that's how you can get other points on the line. So those 2 other points I got were 2, 2, and 3, 3. Now you don't have to, all right, so you don't have to, sorry, someone just came in. I was just wondering who they were. You don't have to show those points. Clearly it doesn't say to show them, but it's probably a good idea to still do it so you get the curve. Because I did see some people do, I might do it in a different color than green. Oh, we'll do it in orange. They went up along the asymptote through that x-intercept, but then went way down like that. So you really need to be careful with the shape of your graph, and the best way to do it is to just find some other points. All right, moving on to question number 4. All right, so finding the inverse, this was done really well. What was not done well is people left their answer as y equals. Remember, if you're asked to do the inverse, then you need to change it as f of -1x. All right, you need to use that notation. The range was done well, and the domain, just make sure you had a curved bracket here. I didn't see many with a squared bracket, but was done really well. Yeah, so happy with that one. Question 5, again, this question was done well last time. So main thing is you need to have the smallest number first and then the largest when you're doing your domain and range. Okay, you can't have them around the other way. All right, just think about when you're counting, we usually count up. So you need to put your lowest number and then your highest number, and the period was done well. I was really happy with that question. That was done well last time as well. Okay, question 6, probably about a 50% pass rate for this one. So a lot of you got x equals -pi and pi in your solutions, but you may have also got other solutions in there. So just make sure that you find just the required solutions, because if you had additional ones, then it's wrong, because we've got this domain here, -2pi to 2pi. So we got to think about that. If you had other solutions, they would have been outside that set domain. Now, in finding your answer, again, you need to know your exact values. So if you didn't get pi on 3, you're already 0 out of 2 marks. Okay, you needed to get that pi on 3. And it's a cos, so we are positive in the first and the fourth quadrant. Now, you need to take note of your your domain. So I have been telling you to change your domain, which is what I did here. It's a bit of a pain, this one, because we're dividing it by 3. So basically we're going from negative 2 pi on 3 to 2 pi on 3. So it does require a little bit more thinking. They're not as straightforward as other ones we've done, but then again, not too difficult. So pi on 3 is definitely within that domain, and negative pi on 3 is also within that domain. Now, this is where a lot of you are making an error. Whoops, I don't want it yellow. I want it blue. All right, so some of you are doing, to get rid of that 3, you're incorrectly multiplying the denominator as opposed to the numerator. So I might just do this down the bottom. If I had, let's do x on the top. If I had x on 3 and I wanted to get rid of, let's just make it equal to half, and I wanted to get rid of the 3 on the bottom, I multiply both sides by 3. So they go, so x is equal to 3 on 2. Okay, a lot of you were multiplying the denominator because you're used to seeing the term 3x or 2x or something like that as opposed to the fraction. So if I had 3x equals a half, to undo that 3, I multiply by 1/3. And that's when your denominator changes. All right, so just be careful of that. That was an error I saw, and it was such a shame because you got everything else right. You just made that last error, changing that 3x to x. All right, question number 7. So here we've got a general solution. So the type of question was very similar to last time. It says x is an element of R. So a little bit different to the previous one where we're solving between negative 2 pi and 2 pi. Here it can be any real value. So we're basically asking for the general solution. So getting your exact value, which is pi on 4, and then setting up your 2 solutions. So we have so it's sine, so we have a solution in the first quadrant and the second quadrant. So just looking at your first quadrant, we go from even values of pi. All right, so that's what the 2n pi is. So whatever I substitute in n for n, I'm going to get an even number. So it could be 0 pi, 2 pi, 4 pi, 6 pi, etc. So your even pi's are on the right hand side. So that's what the general solution of 2n pi means. So your first solution is 2n pi plus pi on 4. Then from the other side, we're on our even pi's. So to make them, not even, our odd pi's. So to make them odd, we just add 1. All right, so whatever I substitute in for n, I'm going to get odd pi's. So I get 1 pi, 3 pi, 5 pi, etc. All right, so this is our even side over here, and this is our odd side over here. So because my solution is in the first quadrant, I'm subtracting pi on 4. All right, so we need to solve for x, so we need to get rid of this 3 by dividing by 3. Now, some of you just divided the whole thing by 3. You shouldn't really leave a fraction within a fraction. So if we divide the first term by 3, we get this, and pi on 4 divided by 3, we get pi on 12. All right, so just not leaving a fraction within a fraction. Then for your other solution, dividing by, oh, actually what I did first is we expanded this bracket. Oops. So we multiplied that pi by 2n and 1. So that gave me 2n pi plus pi minus pi on 4. And then this part here is where the 3 pi on 4 comes from. So 4 pi on 4 minus pi on 4, if you're wondering what that 3 pi on 4 is. All right, so then we divided both sides by 3. So this term becomes 2 on 3 n pi. And then the 3 pi on 4 divided by 3, or multiplying by 1/3, gives me 3 pi on 12, and that simplifies to the pi on 4. All right, so a little bit of fraction work there that I skipped because we're running out of room. but hopefully you got that. That was done really well. Just remember, you do need to state where n is an integer. If you don't do that, you don't get full marks, which is a real shame, because you've got a lot of work there and just writing a few letters extra and you lost a mark. So just make sure you define what n is. All right, question 8. Oh, such an improvement on last week, guys. It was good to see. A lot of you got the correct asymptotes. You got the correct x-intercepts. Some of you didn't label them, which was a little bit annoying because you'll lose marks. So it tells you, clearly label your asymptotes, guys, and your axes-intercepts with their coordinates and the coordinates of the endpoints. So the endpoints are probably the trickiest ones. So you can see on the right side my working out for the asymptotes and the x-intercepts. For your endpoints, we have an endpoint here at, so x equals 0. So we just need to substitute in x equals 0 into the equation. And then we have an endpoint at 2 pi. So we need to find that as well. All right, so just making sure you do all that to get the 3 marks, but such an improvement on last week, which was fantastic to see. All right, question 9, I actually should have put the plus k. Oops, sorry, why don't you highlight the plus k? So the graph has actually been translated down. Maybe last week's one wasn't translated and I've got to add that in. So a lot of you put in the -1, you notice that it was shifted down. It's a positive cos graph, so A is positive. If it was reflected, it would be negative, so just be careful of that. But yeah, otherwise done really well. I'm really loving seeing how you're doing the periods. You're doing really well with that, so good job. And question 10 was a huge improvement on last week, and I'm wondering if people use their calculators, because I saw a lot of people get the answers, but previous questions told me you may not have watched the video. But anyway, so with this one, we have an amplitude, where is my function? We have an amplitude of 3. And this graph has a maximum at 4 and a minimum at -2. So basically our range has gone from -3 to 3 if we just had a standard 3 cos x, but we've got it translation. So it's now become -2 to 4. So what happened to make it go from -3,3 to -2,4? So basically we've had a vertical translation. It's shifted up 1. So that means B is equal to 1. So once you find B, then you can work out A, and you can see my working out for A there. Very similar question to last week. All right, question 11. So introducing some differentiation into this one. So just using the chain rule, this was done well. If you got this one wrong, you probably made a few errors with your negatives. Remember, when you square a negative number, you get a positive. Some people forgetting to put that 2 there. Yeah, but otherwise done well. All right, second one, another chain rule. And I loved, so this is your final answer. You do not need to rationalize the denominator, mind you, but I did see a lot of you rationalize the denominator and get √6 on 3, which was fantastic to see. But that question was done really well and just left as a third, and you guys were happy with that, so that's good. All right, so this one not done so as well. I think a lot of you are seeing it as a product rule. So this is cos 2x is a part, it's a composite function basically. It is a part of your log function. It is not 2 separate functions. So it's not a product function, it's a composite function. So what we need to use is the chain rule. Okay, so if it was a product rule, we would have log base e of x. That's one function. All right, but notice how the x component is this cos 2x. All right, so it's using the chain rule, so a bit of a trickier one. A lot of you left the answer like this, which was fine. All right, so sine over cos, but hopefully you remember, and a lot of you did, that sine over cos is tan. So negative tan 2x was also an acceptable answer. All right, moving on to question 14. So here we've got the product rule. So we've got 3x squared times sine 2x. So you can see we're clearly multiplying two functions. So we've got 3x squared times sine 2x. All right, sorry, I'll just start again because the cleaners came in. All right, so 3x squared times sine 2x. So you can clearly see we've got a product function here. So we've got two functions multiplying each other. So a little bit different to the previous one, which was a composite function. All right, so when you've got a product function, you're just letting u equal one of those functions and v equal the other one. This was done really well, even the substituting of pi, knowing your exact values, which was fantastic to see. So 6 pi squared. And the last one was done really well, except for one thing. So we used the quotient rule, or you can see I've turned it into a product function, because I just prefer the product rule over the quotient rule, and I did it that way, but you could also use the quotient rule. Now the biggest error people made, they got the right derivative and they could substitute in 1, but they were saying e to the power of 1 is 0, which it is not. All right, that is not correct. So that's basically saying 2 to the power of 1 is 0, which is also not correct. 2 to the power of 1 is 2. So e to the power of 1 is just e. I think what you're confusing is e to the power of 0 is 1. All right, so anything to the power of 0 is 1, but not anything to the power of 1 is 0. In fact, you cannot have a power and get it equal to 0. All right, it does not exist. That's why your graph of an exponential is the way it is. So let me just quickly draw it. You have a asymptote on your x-axis. So it goes like that. All right, and never crosses that x-axis. It can never be 0. All right, guys, good work. Bye.